Hey everyone, I hope this podcast and my blog and books have been helpful resources for you and will continue to be. But if you've been struggling with a chronic health problem and are feeling stuck, consider coming to work with my team and me at the California Center for Functional Medicine. We work with patients all over the US and have experience treating a wide range of conditions, including GI problems, autoimmunity, hypothyroidism, cognitive mood and behavioral issues, weight gain and metabolic dysfunction, and more. Our unique model teams clinicians with nurse practitioners and health coaches, all of whom are trained in my ADAPT framework approach to provide a high level of care to our patients. This means more support between appointments, personalized guidance on diet, lifestyle, and behavior change, a cutting-edge patient portal with 24/7 access to your labs and records, handouts and resources to guide your protocols, and a team of practitioners working together on your case. We're currently accepting new patients, so if you'd like to learn more, visit kriskresser.com/become-a-patient. Hey everyone, Kris Kross here with a brief message before we begin the podcast. Imagine a career that draws on your passion for wellness and disease prevention, that harnesses your ability to support and connect with others, that helps you to develop as a person while you help others to do the same. What if you could earn a living while making an impact on thousands of people's lives and even on the future of healthcare? That'd be pretty great, right? Well, that job does exist. It's the job of a health coach. And I believe that health coaches will play a crucial role in the future of medicine, not only in the US, but around the world. 1 in 2 Americans now has a chronic disease, and 1 in 4 have multiple chronic diseases. Chronic disease is destroying our quality of life, shortening our lifespan, bankrupting governments, and threatening the health of future generations. And our medical model is not prepared to address it. Why? Because the only way to prevent or reverse chronic disease is by changing our diet, lifestyle, and behavior. And conventional medicine is simply not set up to do this. Bottom line, we need people who can provide this support to help people make the changes they need to make to save their lives. We need empathetic and compassionate people with a skill for connecting and a passion for change. And my job is to make sure they have all the training they need to do their job so well they will change the future of healthcare. A career as a health coach can be incredibly fulfilling both professionally and personally. It really could change your life, and it can also change the world. That's why I'm excited to announce that we're launching the ADAPT Health Coach Training Program. It's a 12-month, 100% online certification that will prepare you for a successful career as a health coach. It includes training in core coaching skills, functional health, ancestral diet and lifestyle, and professional development. And it's unlike any other health coach training program currently available. To be notified when enrollment opens and to learn more about the program, visit kresser.co/success. That's KRESSER.co/success. Now on to the show. Hey everybody, welcome to another episode of Revolution Health Radio. This week I'm really excited to welcome Dr. David Sinclair as my guest. Dr. Sinclair is a professor in the Department of Genetics and co-director of the Paul F. Glenn Center for the Biology of Aging at Harvard Medical School, where he and his colleagues study the molecular causes of aging and how to improve health span and lifespan by slowing its effects. David's the author of the new book, Lifespan, Why We Age and Why We Don't Have to, which came out on September 10th of this year and has spent multiple weeks on the New York Times bestseller list. David has been named one of Time Magazine's 100 most influential people in the world, and while he now lives in Boston, he has even been knighted in his home country of Australia. So I'm really looking forward to talking to Dr. Sinclair about aging and health span and the various things that we can do to improve our health span and reduce or mitigate the impact of aging. Let's dive in. Dr. David Sinclair, welcome to the podcast. I've really been looking forward to this.
Hey, Kris. Yeah, I'm looking forward to it as well.
So I thought we'd start with kind of a 30,000-foot view question. You work in the Department of Genetics and spend a lot of time thinking about genes and the contribution of genes to our health span and just lifespan in general. So what do you think at this point in terms of the contribution that genes make to Healthspan versus the exposome, environmental factors, sleep, stress management, nutrition, physical activity, air pollution, all of the environmental factors that we are exposed to on a daily basis.
Well, here's where the good news is. Through twin studies, people have calculated the influence of genetics on longevity and health span. And it's surprisingly low. It's very disappointing for geneticists like me, but it's estimated to only be 20%. But then, if you look at the glass half full, what that means is that something like 80% is now in our own control, and we can greatly affect how we will be in terms of health in our old age. And that, for me, that's actually been one of the most important messages that I've been spreading, and I write about in my book, which is often we feel powerless. We think, well, I'm going to die at 75. My dad did, my mother did. This is my lot in life. It's not true. You can have a massive difference. If you do just some very simple things in life, it's estimated you can live another 14 years over someone who doesn't bother.
Yeah, I actually wrote an email recently about that study that it was something around 12 to 14 years of life for just following the top 5 health behaviors. Nothing fancy, not talking about intermittent fasting or, biohacking or anything like that. Just maintaining a healthy weight, getting enough exercise, not smoking, not drinking excessively, and getting enough sleep and, eating well. That's a really empowering message. And I wanted to start there because I agree with you. I think a lot of people can be fatalistic and unnecessarily so based on what the data are telling us.
Yeah, absolutely. And what does that mean for people like you and me and the listeners? If, we already, most of us don't smoke, we already eat well. So how far can we push it? Can we get another 20, 25 years? And that's what I think is really the cutting edge. And what we're going to talk about today is how do you go beyond just those simple 5 things?
Right. So I also want another kind of 30,000 foot view question, which I think can be helpful in framing the discussion is what is aging? Why do we age in the first place? It seems it's like a deceptively simple question, but one that hasn't been easy to answer until maybe recently.
Well, that's true. And what I've come to the conclusion and put forward a new hypothesis is that if you boil down everything that happens during aging, the diseases that occur, the cellular changes that we know occur, the loss of stem cells, the senescent cells, nutrient deregulation, the long list, telomere shortening, the ends of chromosomes get shorter. I've been pondering this for many, many years. And when I distilled it down into what I thought was truly going on to drive all of those things, it came down to an equation, a mathematical equation. And earlier in this year, I went to the premier conference on aging run by the journal Nature. And I was in Amsterdam. And my first slide was, I like to push people's buttons, wake them up. I said, in my view, aging is this. And I showed an equation. And it got a few chuckles. I think some people thought that I was insane. But what that equation was information lost due to entropy. And what that simply means is the information that we get from our parents and we perfect in the womb when we're born, we're working optimally usually, that information is lost over time. And that is what I believe leads us into a world of pain and suffering in our 7th, 8th, and 9th decades.
So would it be correct then to say that the primary driver of that information loss is environmental, all the factors that we were just discussing?
For most of us, yes. I mean, most of us don't have the beautiful combination of centenarian genes that some families are blessed with. So for most of us, we have extra work to do. And some of the genes that we work on, they're called sirtuins. The SIR in the name stands for silent information regulator. The information part of that name was one of the clues to this hypothesis. And these SIR proteins, there are 7 of them in different flavors in the body. They protect the body, they preserve information. But what we discovered in the early 2000s in my lab is that they are responsive to the environment when the organism, in this case, we were studying yeast cells, but we have a lot of evidence from now thousands of papers around the world that it's true in our bodies as well. These sirtuins, they sense when there's adversity. They perceive adversity. So how do you trick your body into thinking that you might die? Well, it's go hungry. You might run out of food. Run. You're being chased by a saber-toothed tiger. Be hot, be cold. The environment's changing. And these and other things are what wake the body up out of its state of complacency. The problem is actually that because most of the 20th century was companies trying to give us perfect luxury, enough food, we don't need to run, we don't need to walk anywhere. We've done a great job at shutting down those longevity protective factors. And over time, our cells lose their information and cease functioning. And that is actually what I think is now limiting our lifespan.
Mm-hmm. Reminds me of the movie WALL-E. Have you ever seen that?
Exactly.
So if you look at it this way, aging is information loss due to entropy, would you classify aging as a disease?
I definitely would, for many reasons, not just molecular. If you look at the definition of aging, and it sits on my shelf in a book called the Merck Manual of Geriatrics, if you go to disease, the definition is it's a process that happens over time that causes disability, dysfunction, and often death. So if you now turn to aging, a process that over time causes dysfunction, suffering, and death. And you say, well, that sounds a lot like a disease. Why don't we put aging in the same category as at least a medical condition? Turns out that if something that happens as a disease that happens to more than 50% of us, we put it in that bucket of aging because it's natural. And I'm quite militant about this. Just because something happens to 49% and we tackle it with billions of dollars versus something that happens to 51 and we say, well, that's natural, too bad, we've got to deal with it. That's insanity. If an alien civilization came down to look at humans and judged us, they would say, of all the stupid things you're doing besides climate change, ignoring what's causing most of you to be sick and die is the second dumbest thing we've ever seen a species do.
I couldn't agree more. I often say there's a big difference between what's common and what's normal. It's now common for humans to be obese in the US, but we know from anthropological studies of extant hunter-gatherer populations, and even just looking back in our own history 50 to 60 years ago, that's not a normal condition for humanity. But I think we become so accustomed to what is common, we start to believe that that's normal. I've had so many patients come to me and say, oh, I started having this problem and that problem. I went to my doctor and she just shrugged and said, you're aging. And, what's the problem with that hypothesis?
It drives me insane. One of the things I write about is we should be treated all the same, no matter what age we are. Right? How many doctors have said, well, you're not 40 anymore. Big deal. You're supposed to ache. You're supposed to get diabetes. No, right. It'd be like saying, oh, most people get cancer if they live long enough. We won't do anything about that. That's just part of natural living. We don't do that. We rail against these diseases. We hit them on the head one by one in what I call whack-a-mole medicine. Right. But the problem with that approach is you're really only tackling the very last symptoms of aging. And you're going to have very little effect overall. Even if you cured cancer in the world today, you only get about 2 to 3 years on average extra life, which is not a big deal. We need to address what's causing all of these diseases. And there is a single cause, I believe. So if we can go upstream and dam the upstream part of the river, we would have a much better outcome than trying to dam these way down with 15 different medicines that all have side effects and interact with each other sometimes in bad ways. But yeah, the medical profession, I'm not sure if they're upset with me. I haven't heard any major pushback. But behind the scenes, they might be saying, this Sinclair guy is a real menace because he's saying that the way we practice medicine right now is the wrong way to be going about it.
That's right. It's disease management rather than true health care. Well, I think we're on the same page there. The obvious question then that comes up if we follow this thread that we've been pursuing is, aging is a loss of information due to entropy. that very clearly then puts aging into the category of a chronic disease. Then the obvious question is, can aging be cured?
Well, I would rather say, can we treat it? A cure is a long way away, maybe not within our lifetimes. I mean, eventually, I think we've got some glimpses into the future that it might be reversible multiple times. But within our lifetime, I think being able to delay aging and push the period of our lives that we're sick into a shorter period, that's really the goal here. And that's doable. Already, we can do that. We know enough about how to activate longevity genes to give us the best chance at a long, healthy life and to die fairly quickly. So the future is here. The question is, how will people adopt it? There are things you can do in your daily life that are easy, and there are some molecules that some of them are natural that I take and my father takes to augment the lifestyles that are never perfect.
Right. So let's do a little bit of a deeper dive into some of the mechanisms, starting with the role of epigenetics and cellular reprogramming. This is a bit of a mouthful, but you talk about the relocalization of chromatin modifiers, RCM hypothesis, in your book. Tell us a little bit about that and its significance in aging and slowing aging.
Yeah. Oh, I'm glad you brought it up. I haven't talked about RCM specifically before publicly, so this will be fun.
Great.
So the fundamental knowledge that you need to have to understand what I'm going to say is that there are two types of information in the cell in our bodies. The one that we all know about is the genetic information we get from our parents in equal amounts, and that's digital information stored as not ones and zeros, but A's and T's and C's and G's. And that's very robust. You can boil DNA, you can extract it from mummies, and there's very little evidence that mutations are so abundant in old people that they're driving the aging process. Now, there's some nuances. I think mutations in mitochondrial DNA, they have their own genome, little mitochondrial power packs.
Yes.
They contribute to aging later in life. But what we've found in others is that these mutations are not common in midlife, and you can actually reverse mitochondrial aging very quickly. We've got molecules that we can turn mitochondrial age and function back within a matter of days. So what we've been left with is a question of, well, if it is information, what type of information could it possibly be? And having discovered these or linked these sirtuin genes, these silent information regulators to aging, way back when I was in my 20s, working at MIT, the lab of Lenny Guarenti deserves some credit here for sure. What I realized was that, more importantly, it was the loss of epigenetic information. So what's epigenetic information? That's just the structures that control how the DNA is read. And we don't turn on every gene in every cell, otherwise we'd be the world's biggest tumor. What we have is essentially a piano, not with 80 keys, but with 20,000 or so keys, each one being a different gene. And the music is different for a nerve cell and for a skin cell, for a liver cell. And it's played beautifully when we're young. But what I'm saying is that over time, the structures that play the right genes at the right time become messed up. And skin cells start playing genes or notes that should be only on in liver, and a brain cell becomes more like a skin cell. And it's a real cacophony. So what we've been trying to figure out is what causes those notes to get messed up, and can we reset the pianist so that he or she plays the beautiful symphony of our youth? Now, one other thing to know is, what is the epigenome? It sounds complicated, but really it's just, at its essence, the structures that control whether a gene is on or off. And if you go to the very fundamental level, boil it down, what's happening is that DNA that you want switched off for your life, silenced, in other words, get bundled up very tightly, like a hose would be spooled on your driveway in loops. And genes that you want on, for most of the time, you put them in big open loops that are looped out so the cell can access them and read those genes. So it's a code, but instead of it ACTG, it's actually loop, bundle, bundle, loop, loop, bundle, bundle. And what controls those loops in part are chemicals called methyls. It's just a carbon with 3 hydrogens on it. Those glom onto DNA over time, and we can read the what seems to be like plaque on your teeth, or crust, think of it, a crust on our DNA. And that messes up these loops and bundles so that cells start reading the wrong genes at the wrong time and lose their identity and function. And I think what's happening as an outcome is that we become susceptible to cancer, to heart disease, to Alzheimer's. So with all of that, what I can tell you is, if I took your blood, Kris, I could tell you quite accurately how old you are biologically, not based on your candles, but on your actual biological age. I suspect that you'd be younger than your actual age. But those people who smoke and are obese and don't do any exercise, they are typically older than their actual age. And we can measure that crust on the DNA. And that means their cells have lost their epigenetic information over time.
Right. So the epigenetic modification of the cells is, of course, one of the mechanisms that is determining our actual age, as you put it. And methylation is one of the mechanisms that affects epigenetics. And of course, we have lots of research that suggests that things like nutrition and exercise and sleep affect methylation. So it's another way that the choices that we make on a daily basis are, driving our health on a molecular level.
It's really true. So when you eat a high fat, a terrible meal, let's say you've had a giant soda and, processed food, you might say, well, it doesn't hurt me. It'll be out of my system in 24 hours. I can forget about it. My body's just a trash can anyway. But what we've realized is that this clock, it's always moving forward. As far as we know, it's pretty hard to reverse it, but we're getting there. But yet, I now view my body differently than I did just a few years ago. If you recognize that there's a clock ticking, everything you do that's bad will accumulate, and everything you do that's good will slow that process. And so you don't get away with anything, right? Your body is registering what you do to it every day. And so I've been much more careful about what I eat, thinking that, I used to think I could get away with it, but I really don't think we can. And you need to be vigilant over decades for this to work.
Yeah, it really needs to become a habit and a pattern that's just built in, rather than something you occasionally do, if I have New Year's resolutions or something like that.
And you don't want to start when you're 60 or 70, if you can help it, because the clock is ticking, and trying to rewind it's pretty hard. So
right.
Yeah, I wish I'd started even earlier in my life. I started in my 20s on exercise and diet, and but really only rigorously fasting over the last few years.
So let's talk a little bit about the mitochondria and the role that they play in aging, because I think after that, some of the specific interventions and things that we're going to talk about affect the mitochondria, and that's one of the main ways that those interventions can help us. So tell us a little, just generally about the role of the mitochondria in aging.
Well, every time my lab studies aging, we end up bumping into the mitochondria. So it's definitely telling us something. It's definitely one of what we call the 8 hallmarks of aging. And probably everybody who's listening is educated enough to know mitochondria generate a lot of the energy for the body in the form of chemicals, one called ATP, which if we do without, we're dead in about 10 seconds. So we've got to have mitochondria. It's the reason we breathe oxygen, because mitochondria essentially combust it and generate ATP out of the sugar. But what we find is mitochondrial number and activity goes down. In our muscle, we can have hundreds of these per cell, and we lose them, and they do become less active. So what can you do? Well, the sirtuin genes promote mitochondrial biogenesis, we call it. So we get more mitochondria, and they become more active. And we found that we can pretty quickly boost the activity of mitochondria, either using sirtuin activating molecules like resveratrol from red wine, but also more recently, we've been working on what are called NAD booster molecules. And I'm actually in the office of a company that I've co-founded in full disclosure. I just happened to be out here today discussing the results from clinical trials. And we're hoping that the NAD booster that we're developing will help patients who suffer from mitochondrial diseases or a lack of energy. And after 2 years of research so far in humans, looks like we're on the right path, and we'll probably know the answer to these questions by the end of next year.
Wow, that's exciting. You mentioned CERT earlier, but I want to go into more specifics on CERT T1 and discoveries on how that relates to NAD plus, because I know that's one of the molecules you're a fan of, and we'll be talking about. So, want folks to understand the basis of that.
Right. So the sirtuin genes, as I mentioned, there are 7 of these. They do different things. That they're in three of them are actually physically in the mitochondria with enzymes. So just a baseline of knowledge. These genes produce enzymes that then move to different parts of the cell to take care of different activities. So 3 of those enzymes are in mitochondria. 3 of them are in the nucleus, taking care of the genome and the epigenome, silencing genes, repairing genes. And there's one lonely sirtuin number 2 in the cytoplasm in between the mitochondria and the nucleus. And they do wonderful things, but they don't work efficiently unless they have an accelerator pedal pushed and the fuel. So they have an accelerator pedal. Essentially, it's a protein arm that sticks out that when, say, a molecule like resveratrol from red wine sticks to it, it will do a maneuver like a bear hug and it'll be more active. So that's the accelerator. But the fuel, which is, you could argue, even more important for a car, in this case, the enzyme, is actually a molecule we make when we're alive. We've got probably 20 or so grams of NAD in our body. NAD is a small molecule that the sirtuins are sensing. And so we need NAD anyway. So NAD is in all high school textbooks as a molecule that is used in mitochondria to make energy and to make new metabolites. So it's very important, but it's extremely boring. We typically learn it and then forget it in high school. But NAD has experienced a renaissance because these enzymes are sensing the NAD concentrations in the cell. And unfortunately, we think as we get older, we make less NAD and we consume more of it. So that by the time we're 50, if you take a skin sample, it'll have half the levels of NAD that you had when you were 20. We definitely see this in mice too. So we've taken the approach of either providing the accelerator pedal or the NAD boosting molecules, which we usually use are precursors, molecules that the cell can turn into NAD quickly. And those raise the NAD level back up to being young again or beyond. We can get the levels up about 2 to 3-fold in mice and in people. And then at least in mice, we see remarkable things happen to those mice. We see rejuvenation of mitochondria. We see lowering of inflammation. We see a dampening of the hypoxic response, which drives inflammation. And we also see a growth of new blood vessels in muscle as though the mice had been exercising. And then when we put those mice after 3 weeks on the molecule, they actually act as though they have the physical endurance of mice that have been exercising and are much younger. Specifically, 2-year-old mice could outpace the young mice of just 2 months. And they get less lactate, so they don't get the lactate burn, and their blood flow is beautiful. So their muscles are perfused and the toxins get taken out by the muscle. And if you have an occlusion, if we block the femoral artery and give our precursor, raise up NAD, they will reroute the blood vessels much more quickly and recover. So that could be useful for someone who has a blockage as well.
That's really exciting. And I've read a lot about NAD, and it seems like I don't think there are that many panacea type of molecules, but NAD certainly seems like one of the most promising at this point. I want to come back to how to boost NAD when we talk about some of the other specific interventions that you are doing yourself and that you recommend. But before we do that, I want to kind of frame the bigger picture again. So let's say somebody is currently living a relatively standard American lifestyle. They're not eating that well. They're not getting a lot of sleep. They're fairly sedentary. What I see sometimes, what concerns me is there are some folks that will skip the healthy diet, healthy lifestyle and go right to taking resveratrol or NMN or, some of the other things that certainly can have an impact on health span and lifespan. And I don't think that taking them would be a bad idea in that situation. In fact, you could argue that it's a really good idea. But there's sometimes a mentality where if I just do these things and I get a free pass and I don't have to worry about the diet and lifestyle piece. I'm assuming you think that's a bad idea.
Well, it's certainly not giving you the best chance at a long, healthy life. And we also know that exercise and fasting will work from large studies of people, and NMN and other NAD boosters, and to a lesser extent resveratrol. We don't know if they work in the long run. And so, yeah, anyone who thinks they can just take an NAD booster, really you're just hoping that the mouse results will translate to humans. We don't actually know that yet. So the best bang for your buck is to do the right things with exercise and diet. And I'm actually myself taking some of these molecules, because there's very little downside that I know of. But there's also another fact. There's a third thing that most people don't know. We study resveratrol and NMN, the precursor we use in the lab, and the one that I take. We combine that with healthy diets and exercise. And what we find is that they're additive. They're not substitutes. Well, they are partial substitutes, but when you add them, you get the best bang for the buck. For example, a little known fact. When we gave resveratrol to mice that were on a Western diet, okay, they were healthy like a lean mouse. But if we gave resveratrol to mice that were periodically fasted, we got mice that lived longer than any other group. So it was an additive to fasting, and the fasting was an additive to resveratrol, right? So that means that you want to do both. In the case of the NMN, what we did was we combined exercise with NMN. And even though NMN mimicked exercise, when the young mice were exercised on top of NMN, they ran the furthest of any mice we've ever had in the lab. In fact, one of them broke the treadmill because it ran so fast. So really, it's not an excuse. It doesn't fully substitute for having a healthy lifestyle. But honestly, for people like me, who I spend my time sitting in chairs and airplanes and typing, I really need some help. I do what I can, but
Yes.
Some of us need more help than others.
Absolutely. We're all fighting against this mismatch of the modern lifestyle and what our genes are really programmed for. I don't know anybody who's like living 100% the way that would be optimal at this point. So I agree. It's anything that can help to mitigate those effects is welcome.
And Kris, we may not be able to live optimally. There may be downsides to running and fasting that we don't know, that the mice are showing can be offset by adding in something a little extra.
Absolutely. What about the contribution of things like sauna? You mentioned hot and cold. So sauna, or, doing cold plunges, or, you've talked about fasting, both there's extended fasting and intermittent fasting, and other, let's say, more advanced strategies that might have an impact on epigenetics and mitochondrial function. Is there a way to sort of quantify or qualitatively assess the impact of those strategies collectively versus things like NAD boosters or resveratrol or even metformin, which we'll talk about?
Yeah. Well, so the hot and cold concept, even though we were the first people in my lab to show in yeast cells that increases in temperature, low amounts of protein, low amounts of sugar were extending their lifespan and health by the same mechanism. In fact, these sirtuin genes and NAD, we showed way back in 2003, we're all working through the same mechanism, which now we kind of take for granted. But in those days, it was a real shock to the scientific community that exercise and diet and heat had anything to do with each other. I think still some people think differently.
Right.
But I still was pretty skeptical that you could go in a sauna and that would be enough to activate your longevity pathways, or cold for that matter. But for my book, I started researching it. In fact, to be honest, I was prodded by my editor, who said, people will want to know about this cryotherapy.
Mm-hmm.
And I said, I'm a world-class researcher, at least I'm trying to be. If I start talking about these things, no one will take me seriously. But I started to look into it, and actually the data was surprisingly compelling. I wouldn't say a proof, But if you look at thousands, in one study, 10,000 Finnish men who go to the sauna or go to their own home sauna 3 times a week or more, the rates of cardiovascular disease were reduced by, it was between 30 and 40%. I don't remember the exact number. Those were really compelling. Now, there's always downsides, right? And I know you know the literature really well, that maybe if you're in the hospital or you're sick, you're not going to go to the sauna, and that biases the study.
Right.
But I'd read enough to make me convinced that saunas are likely to be healthy for many reasons, and also nothing less might actually make you feel good as well, which it does. So I've gone now to weekly sauna baths, and also the cold. Let me talk about cold. I dip in a cold tub for as long as I can. Usually it's only for a few minutes. My son, Benjamin, who comes with me, likes to stand in there for 15 minutes. It's crazy. Mind you, he's got a little bit of extra padding on him, which is another story. But hopefully he won't be listening to the show. But so the cold story also makes scientific sense. There's a sirtuin called number 3, which resides in mitochondria, and it is involved in making brown fat when the skin is cold. And what we found in mice is that mice with brown fat are very healthy. And it's for 2 reasons. Brown fat is highly metabolic. It's full of mitochondria. So your metabolism will be revved up and you'll burn off energy, which is good with our lifestyles these days. But it also, we think that brown fat, or even beige fat, which is something in between white and brown, give off these molecules. Many of them we don't know what they are yet, but it does seem as though they are protective against things like inflammation in the body. I was recently out at a university where I spoke to a scientist who was studying brown fat conversion. They put the mice in a cold room and they get brown fat. What he told me was that if you put old mice in the cold room, they barely get any brown fat. Now, if that's true in humans, it means you better start early to build up your brown fat stores, because it may be too late by the time you're, say, a 60 or 70-year-old.
One thing, I'm a lifelong surfer, and one thing I've always noticed, it's interesting, is you don't see many fat surfers. And I've always wondered about that because, in other sports, you'll see people, even who are exercising regularly, who are significantly overweight. My theory has always been that the cold exposure that comes, even in relatively warm water, is still colder than body temperature. And if you're spending a significant amount of time in that water, my guess is that has metabolic benefits that are persistent over time.
Right. Well, I'd be shocked if that wasn't true. I think we can assume that it's likely. And one of the things that's interesting is, if you're not a surfer, what can you do? Well, you can jump in ice cold baths, or you can go for a walk out in the snow if you're on the East Coast here or in the Midwest. But another thing you can do, which I increasingly practice, is I don't bundle up. During the day, if I'm in a building, I'm wearing a t-shirt if I can. And at night, one of the big biohacks, life hacks, is don't snuggle under a really hot blanket.
Right.
I like to wear a sheet. And first of all, I sleep better, I've found, but also you're actually radiating heat. And that is the easiest way to burn off energy.
Mm-hmm. Yeah, it's interesting to frame this in the context of comfort versus discomfort. Like you started talking about that at the beginning of the podcast. We've gone out of our way to ensure comfort, so that we're never cold, we're never hot, we're always, sitting in a comfortable chair. We never feel hunger because there's always food available, at all times. And we're seeing now there's some real downsides to a life that is characterized only by comfort and never by experiencing discomfort, which would have been a normal part of our ancestral experience.
Mm-hmm. Right. And in fact, we've done a very poor job at putting our bodies into that defensive state called hormesis. We've done the opposite. So we have to avoid everything. Don't have to, but the goal is to avoid everything that makes you feel perfectly comfortable. Get out of your comfort zone. Not to the point where you want to quit, but skipping breakfast and occasionally skipping lunch is what I do. Yeah. And that's not difficult at all. Actually, I feel a lot better because of it. But these things are very doable. You mentioned long-term fasting rather than just intermittent fasting. I think that's probably even better if you can go for a whole day or even 3 days, or like our friend Peter Attia does for a whole week every quarter. I think that's even better if you can do it. I haven't been able to, just with my busy schedule. I'd probably lose my mind or kill somebody that I work with.
Yeah.
But yeah. And it does. There are downsides to that, right? You do get aggressive. Our mice, when we put them on calorie restriction, they attack each other in the cage. So this is a real thing. But for me, skipping breakfast is something I know works for me, because I've also measured my blood sugar. I have one of the glucose monitors that you stick in your skin, and I can see that my body makes glucose just before I wake up, and I'm not hungry. And it's insanity for me to be eating cereal in the morning if my body already has more than enough sugar.
Mm-hmm. Right. And then there are kind of in between approaches, like the fasting mimicking diet, Walter Longo's approach. And so, lots of different ways for people to experiment with fasting. And I don't think, it seems like we don't have enough data yet to really compare the relative benefits from one of those approaches to another, but they're all better than nothing at all, I think we could say.
I couldn't have said it better myself. Now, Walter is an opinionated guy, good friend of mine, and we will argue over a glass of wine or a cocktail at these conferences. And he's pretty militant. Whatever he thinks, usually he says is the best way. But you're right, actually. When you really get down to it, nobody knows the optimum. We're at a point in history where we know generally what works, and what it's probably going to boil down to is it's different for everybody. People have different microbiomes, they have different genetics, they have different lifestyles, they have different determination, and one will work for somebody versus another. And that's why I'm very much into measuring your body, because you just don't know. You can follow a recipe in a book of a diet, but if it may not work for you as well as something else. And so that's why I think that the real trick to longevity is to optimize for yourself. So how do you do that? I wear a ring, the Oura Ring. Many people now know about. I talked about it on Joe Rogan's show, and it's sold out. But I think you can buy it now. I've got, of course, the watches on my arm. One watch on my arm that tells me that. Yeah. But I also go further. I mentioned the glucose monitor.
See, you're wearing a CGM.
Yes, I am. Not the super duper one, just the one that you scan with your iPhone and get a reading. Yeah. That works great. And I've learned to rely on it, actually. It's also part of a game. It's like a video game that you play with your body. And then I also do blood tests on occasion through a company that tells me how to optimize myself based on a lot of other people's data and AI. And that's been very useful. I've got over 11 years worth of data now that I can plot to see how I'm doing and if there are long-term bad trends that I need to correct before I get sick.
Yeah, I agree wholeheartedly with that. It's, I think sometimes we can get too wrapped up in the minutia and lose sight of, just doing something in like with fasting, arguing over which type of fasting is best can become a distraction from just doing some fasting, skipping some meals or eating less for a period of time. So,
yeah, the worst case, Kris, is that I've got colleagues who say, these are my scientific colleagues, oh, I'm not going to try that until it's proven to work. Well, yeah. Good luck. We may
be waiting a long time.
Yeah, I'll see you in the afterlife then. I'll miss you when you're gone.
Yeah. All right. Well, I know we've got a few minutes left. I want to talk about the molecule, some of those specific molecules that you like, including NAD boosters. And let's start with that, the best way to boost NAD, and then maybe talk a little bit about resveratrol and even metformin if we have time.
Okay. So the bottom line is we want to turn on these longevity defenses, these enzymes. I've mentioned sirtuins. These are the 7 that I work on. There's another 2 categories of longevity pathway, we call it. One is AMPK, which is the target of metformin. And there's a third one, mTOR, which is the target of rapamycin, a drug that's used to suppress the immune system. But it's evolved to sense the amount of protein that's coming in, typically certain amino acids. But the sirtuins are talking to these other pathways. So if you activate your sirtuins, you're also going to turn down your mTOR and activate your AMPK. So you'll be all good. So how do you do that? Well, sirtuins, you can activate the primary sirtuin called SIRT1, which suppresses epigenetic noise. It protects telomeres. It helps with broken DNA. And so you want to take an accelerator. Well, what I do is I take an accelerator, which is the resveratrol. I take a gram of that, or literally a teaspoon, into a little bit of yogurt that I make every morning. Well, I don't make yogurt every morning. I make a big batch of it. Right. It lasts me for a couple of weeks. And I could talk a whole show about yogurt, actually, but I won't. I'm probably, in my newsletter, going to release the recipe for everybody. So if you want to see the recipe of this special yogurt for my microbiome, sign up for my newsletter. But the point is that, so resveratrol dissolves in yogurt or something fatty, which is what you need. Otherwise, you're basically eating brick dust and it'll go straight through you. And some clinical trials have failed with resveratrol because they didn't know how to deliver it. You can't just pop a dry pill, unfortunately.
Is it tasteless?
Yeah, it's tasteless, but it tastes like chalk.
Right, but and it won't overwhelm the taste of a smoothie or yogurt when you mix it in.
Not at all.
Yeah.
Nope. It may be a little crunchy if you don't dissolve it. That's all.
Right.
But I've been taking that since 2004, and I've got a very clean cardiovascular system. Everything's looking good for someone my age. I'm 50. So that's the resveratrol. I do that in the morning. I don't do it at night because activating SIRT1 will, at night, will screw up your circadian rhythms and you won't sleep very well, we found. Mm-hmm. And that's true in mice. There were a couple of science papers on this back in a decade ago. So that's all scientifically valid. The fuel for these sirtuins is this NAD. If you eat NAD or inject it, it may work. It's controversial. The reason that we suspect it's not as good is because NAD is a very large molecule that needs to be broken down first before it's reconstituted back in cells. And so the molecule that seems to work really well in our hands is called NMN. Long form is called nicotinamide mononucleotide. And it's the immediate precursor to making NAD. It's got the sugar on it. There's a sugar, little ribose molecule, which is the ribose. It's got adenine, which is a piece of DNA. And it's got the nicotinamide. Now, nicotinamide is not nicotine. It's very different. It's not going to act like nicotine. It's more like niacin, vitamin B3. Anyway, that molecule will immediately be turned into NAD by the body. And we find in mice and in humans, it works very effectively. There's another molecule that's sold on the internet called NR, nicotinamide riboside, which is an even smaller molecule. It doesn't have a phosphate on it, so the body needs to pull phosphate from somewhere else to be able to rebuild NAD. Now, this is a whole show as well about the difference between these molecules. There have been a few studies with NR in humans already. Some of them didn't show any market effect for reasons that we don't know yet. But we've seen some positive effects in other studies. For instance, there was a study in ALS that looked good. And there's also one that looked at inflammation, and inflammation went down quite dramatically, actually, in those subjects. But the question is NR the optimum? Is it NMN, or is it something else? And I'm doing trials on some more optimal molecules that we think will work even better than the molecules that you can currently buy on the internet. Long story short, we're at the point where it's do or die for these molecules. A lot of people are taking these molecules because they're very safe. We don't know of any downsides. And the science sounds good. There are a lot of people that claim they feel better, they have more energy, just like the mice do. But as a scientist, I can't say that we have any proof that they work yet.
What are you taking?
So I take NMN with my resveratrol. I take 750 milligrams up to a gram, depending on how I feel on the day. And that seems for me to give me a real boost. If I stop taking NMN, I actually become tired and grumpy and can't be bothered getting out of bed. So for me, it's currently a requirement. Especially when I travel, I find that so I'm going to Australia today. When I get to Sydney, I'm going to take probably a gram of NMN. And I think, I'm not proving anything, but I think it overcomes my jet lag pretty well.
Interesting. Any particular considerations regarding specific delivery mechanism or form, powder versus capsule brand?
Well, I don't jump into brands. A, because I don't test them, and B, because I don't like being in lawsuits. It's happened before.
Yeah.
It's a fairly litigious bunch out there. But what I can say is that I always look for GMP grade material. I look for ultra pure, greater than 98% pure. And NMN, by the way, will taste a bit like burnt popcorn. So if you get that flavor, you have some idea that it's the real deal. But also, please store these molecules in the fridge. They go off on the shelf at room temperature over a matter of months.
Okay.
And that information isn't made freely available.
So are you not mixing that with yogurt? Are you mixing it with water because you don't want your yogurt to taste like burnt popcorn?
Yeah.
Or, yeah.
It dissolves in water, so I just have it with my coffee. So
Right.
I'm not averse to having coffee or tea in the morning. I don't regard that as breaking a fast, nor do I for a couple of spoonfuls of yogurt.
Yeah. Okay. Let's talk a little bit about metformin. I've heard you discuss this on other podcasts, like with our friend Peter and a few others as well. And I know there's still some question marks about it, and especially whether it's beneficial on days that you're exercising. So maybe just a quick summary of why someone might even consider metformin as a health span extension molecule, and then what the considerations are in terms of taking it.
Yep. Right. So metformin will activate the second leg of the stool and augment sirtuins. And we think it works by inhibiting the mitochondria in such a way that the cell responds by making more mitochondria and turning up the mitochondrial activity in the cell. The drug metformin comes from the 1960s and 70s. It's a version of a plant molecule from the lilac plant, French lilac. And what it was found just really by luck is that it makes the body more sensitive to insulin and works very well as the frontline therapy in type 2 diabetes. And so, yeah, you'll lower your blood sugar typically. But what was found was that by studying more than 10,000 patients who have taken metformin for many years and looking at their rates of other diseases besides diabetes, people taking metformin were more protected against cancer, heart disease, frailty, and Alzheimer's than someone who never had diabetes and didn't take the drug, which is remarkable, right? And what that points to is that it's doing more than just treating diabetes. It's actually slowing down aging itself. And so with that data, and that's been reproduced in a few different studies, and knowing that the drug is fairly cheap, and knowing that the drug has very little side effects for 9,999 people, then I've made the calculation that it's worth taking myself, which I do, 500 milligrams in the morning, 500 milligrams at night with food. It can be rough on the stomach, so beware if you do take it. You might feel a little queasy at first, but you can overcome that with food or just over time. Now, you can't just go to your doctor easily and they'll give you metformin. Unfortunately, most doctors haven't heard about this research, and they also are not taught to prescribe medicines to people who don't yet have a disease. So you may have some convincing to do. And I've heard that people have success either taking my book to the doctor as a present or giving them that, or a combination of papers that are referenced in my book.
Yeah, that's I think really another show as well. I think to talk even more about the mechanisms of that, and then how to sequence that in versus exercise, travel, all of that. Yeah, I know we have a couple minutes to give us a kind of Cliff Notes version of that.
Right. So I know what I'm talking about because I've spoken to the scientists who did these studies, and they thought that the pundits overinterpreted the data. What happened was, so because metformin interferes with the mitochondria, you don't get the hypertrophy, you don't get as much muscle building if you're always on metformin. But here's what happened to the elderly people taking metformin. They all gained muscle and they all became just as strong as each other, okay? There was a slight difference in the amount of muscle gained, but there were far more similarities than differences in those groups of no metformin plus metformin. Now, if your only goal in life was to win a weightlifting competition and bulk up, yeah, you probably don't want to take metformin the day that you go to the gym and perhaps the day you recover. But if your goal is to live longer and to have strength and survive if you fall over in your old age, then it's not such a big deal. Now, I'm testing this in my body. I'm trying to skip metformin on days I exercise to see if it makes any difference. But I think that it's not a major concern for most people who are not professional bodybuilders.
Dr. Sinclair, thank you so much for this. It's your wealth of knowledge, and I'm contributing directly to extending people's health span. Must be very satisfying. Where can people find out more about your work? And if they want to kind of stay abreast of new developments, you mentioned you have a newsletter. How can they sign up for that?
Sure. Hopefully people have pens. I guess you can rewind.
Yeah, we'll put it in the show notes too.
Cool. Thank you. On social media, I'm on Twitter at David A. Sinclair. Instagram is David Sinclair, PhD. And my website is lifespanbook.com. And there you'll find history of blogs and newsletters that I put out. You have to sign up by email to the newsletter if you want. You can always opt out if you don't like what I'm writing. But what I try to do is to give updates on things like the Metformin story, on NMN versus NR, which is better and why, or at least what the science says. And even perhaps the next one will be a yogurt recipe if people are interested.
the health span extending morning yogurt recipe. Love it. And of course, check out Dr. Sinclair's book, Lifespan: Why We Age and Why We Don't Have to. It's a very well-researched, thought-provoking, and mind-opening book. I highly recommend it. It was hard for me to put down once I started reading it. And David would love to have you back in the future to talk about, your more recent research and new developments.
Well, thanks, Kris. I love what you do. Keep doing what you do. You're a voice of reason amongst all the radical views. So keep up what you're doing.
I appreciate that. Have a safe trip to Australia, and hopefully your jet lag hack is successful. I'm going to try it myself because I do a fair amount of traveling, and I'm always looking for a little extra support there.
Will do. Thanks a lot.
All right. Take care. Bye-bye.
You too. Bye.
That's the end of this episode of Revolution Health Radio. If you appreciate the show and want to help me create a healthier and happier world, please head over to iTunes and leave us a review. They really do make a difference. If you'd like to ask a question for me to answer on a future episode, you can do that at kriskresser.com/podcast question. You can also leave a suggestion for someone you'd like me to interview there. If you're on social media, you can follow me at twitter.com/Kris Kresser or facebook.com/Kris Kresser L.A.C. I post a lot of articles and research that I do throughout the week there that never makes it to the blog or podcast, so it's a great way to stay abreast of the latest developments. Thanks so much for listening. Talk to you next time.